Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be looking at 10.5, the last of the unit, the last of Integrated Math 2 Semester 2, and we are looking at conditional probability. Conditional probability is an extension of 10.4, but we're looking at probability where we already have some piece of information that's going to limit our total outcomes or the total number of possibilities. It makes a little more sense when you're looking at a sample space typically, but we'll do a few examples and then hopefully it'll make sense here. So let's start out with something like a deck of cards. Okay? Of course, with the cards again, you have your four suits, you have hearts, diamonds, you have clubs, and you have spades. And then you have a total of 13 values going from 2 through 10. And then you have your jack, queen, king, and ace. Okay? So that creates 13 times 4 creates a total of 52 cards. So I could ask you a number of probability questions involving a deck of cards. I could ask you what's the probability of drawing the 2 of hearts. That's 1 out of 52. I could ask you the probability of drawing a 2 out of the deck of cards. That's 4 out of 52. I could ask you the probability of drawing a heart. That's 13 out of 52. So in each of those cases, with the example of the deck of cards, you're taking the probability out of the total number of cards. However, with conditional probability, you're starting out essentially with a smaller subset. So a question like this with conditional probability might be, what's the probability of drawing a heart given that it's a 2? And so conditional probability is always going to have that word written in it, given. And so you're starting with a piece of information. So what's the probability of drawing a heart given that it's a 2? Well, if it's given that it's a 2, then I don't care about the whole deck of cards. If I know that the card is a 2, I'm only looking at 4 cards now, right? So knowing that it's a 2, what's the probability of drawing a heart? Well, there's only 1 heart in that set, so the probability here would be 1 out of 4 instead of 1 out of 52. So whatever you're given, that's going to limit your denominator. It's limiting the number of cards that you are considering, essentially. Now, notation-wise, this is going to be given as the probability. It's going to be given as the probability of A given B. So you're using a line here for given. And that is going to be, move it over a little bit. That's going to be the probability of A and B occurring out of the probability of B occurring. Now that's the formula. I personally don't use this formula when I'm looking at conditional probability. It's easier for me to think of the concept of, okay, well, I'm in the example of the deck of cards, I don't care about the whole set of cards. I know that I have a smaller group. So that's how I think of it as, but you're welcome to, consider it whatever makes more sense. So let's look at another example. What's the probability of drawing a, well, we'll write this out notation-wise. The probability of drawing a heart given that it's a 2, that's what we just did. Now, if I'm using this formula, the probability of A and B would be the fact that it's a heart and a 2, which is 1 out of 52, out of the probability that it's a 2 is 4 out of 52, which, like we said, reduces to 1/4, right? Let's look at a different example. Probability of drawing a king given that it's a heart. So if I'm given that it's a heart, I don't care about the whole set. I know it's a heart. So I'm only looking at the hearts, which are 13 cards. So for me, I would immediately go and put that in my denominator. There are only 13 heart cards. Now, if I put the probability of, drawing a heart 13 out of 52, I'm going to end up with a complex fraction, and those 52s are going to cancel anyways. Okay. Now, how many kings do I have? Okay, well, if I know it's a heart, out of the hearts, there's only one king. So the probability of it drawing a king, given that it's a heart, is 1 out of 13. Okay. Probability of drawing, let's say, we'll make this a little more complicated. Let's drawing a number card, given that it is a diamond. So again, given that it's a diamond, that means there's 13 total cards. And I want the probability of drawing a numbered card. Well, those are 2 through 10. So that would be 9 out of 13. So there are going to be some questions involving a deck of cards, a die, a set of dice, just like we did in 10.4 and 10.1. The other thing that's also going to be included here in 10.5 are questions using a two-way frequency table. This is something that was covered last year and also in the fundamental math class if you took that with me. But in that section, you are looking at a two-way frequency table. Remember that two-way frequency tables are comparing two or more values of something, or collecting data on two different things. So, for instance, let's say I'm comparing ordering food, either a taco or a burrito, and a drink, ordering a soda or water, and there were 100 people total. Okay, in this scenario that ordered food. Okay. So with this, okay, with this, and I'm just putting some numbers here. Remember though that in two-way frequency tables, each row and column has to sum. So let's say 80 ordered soda. We'll say 20 ordered water. Let's say we have 15, 5. 15, 65, 30, 70. Okay. So usually in a normal probability problem, you'd be taking whatever the event is and dividing that out of the total. But with conditional probability, we're not looking at the whole number. Just like in the previous examples, we weren't looking at the whole set of cards. So a question like this might look something like, what's the probability that someone ordered, say, soda, given that they ordered a taco? So you're not looking at the entire total. This is not going to be out of 100. You know that the person ordered a taco. Therefore, the total here isn't going to be 100, but rather it's going to be 30 because a total of 30 people ordered a taco. So out of those people, what's the probability that someone ordered a soda? Well, that's 15. So 15 out of 30, or 1/2. Remember, with probability, you're usually writing it as a simplified fraction. Occasionally you might be asked to do a percentage, so just pay attention to that. The probability that someone ordered a burrito, given that they ordered water. So for this, I'm looking at how many people total ordered water, because that's given. And that was 20. Out of that 20, how many people ordered a burrito? 5. So it's 5 out of 20, or 1/4, or 25% if it asks for a percent. Okay? So you're either looking at a deck of cards, a die, a set of dice, or you're using a two-way frequency table. That's how you calculate conditional probability. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.